Even kijken, ja. Hello everybody. We're live. So I see 4 or 5 people at least on my restream window. And today we have Sebastian in the stream, which was just fixed like 15 minutes ago. So kudos for that, like setting up the entire environment. I think it took you less time than it took me to set the audio on. I hope that both of us are audible in the stream. Crazy, can you confirm? Yeah. No, Sebas. Uh-oh. I think that if I unmute you, that will be a bit better. So, Sebas?
Let's try again. Hello, hello. Good evening.
Come on, crazy. Don't build up the tension. Better. Yeah, so it seems like unmuting people is actually very helpful. Oh my god, people. So, well. I'm blurry as well. First of all, I was almost about to cancel this one because I am so tired, like a week full of work, and I've been working 2 days on B-Sides Newcastle. Hello Groningen. So just finished my hardware hacking workshop at I think 6ish. So there was some mail for me. So I had some cool new stuff like a cam link that I bought, but I cannot get it to work yet. Something hardware hackerish. I want to work on CAN bus and play with my car a bit. There's some other stuff, but I need to use my camera. So I have this setup, which is a HDMI camera set for stuff up close. So I had some other stuff as well, more YOLO, cheaper stuff. This is a little bit more expensive and has some better quality, hopefully. There was something happening last week that I want to tell you about. So I've been doing these hardware hacking workshops. Hello Fahrenheit. The slides volume difference, Boss is a bit quiet, we'll fix that. So
I can fix it on my end as
well. Okay.
I just switched microphones. So let me know how the volume is now.
Cool.
Because I'm now not using the AirPods microphones because those are crap, and I can tune it up if you need me to. So just let me know how the volume is right now. Perfect. And I'll tweak you up a little bit on my side as well. So I think my microphone is boosted multiple times in OBS because some of the streams had the audio so quiet that I need to put it on max volume, and if there was like an ad somehow it would like kill your ears. A little bit lower, yeah. A little bit lower? Oh yeah, but okay, so how is it now? Is this better? I need to disable the auto adjust because that's always crap. So I think this should be better.
I hear you perfectly clear on my side.
Nice. You do hear a hiss, yeah, well.
Balen.
That sucks.
Sorry. Okay, it was like this is my mood for now, and I'm coloring all red here. So I was a little bit on a downside earlier last week. As I was like working on stuff and had the feeling that I needed to grow somehow. So I made some commitment to myself to start improving myself and to get some help from the people outside. I posted some tweets on Twitter like, please help me if you can tell me on how to improve my soldering gesture. I already watched some of the videos by Bas. Those were really helpful. Still haven't done any. I have done. No, I haven't. Haven't done BGA. I only did like.
Me neither.
Okay. SMD stenciling. That's what I did. On BGA chips, but not reballing and that kind of stuff. So I really want to learn going like a level deeper, and I think like the basic stuff, the stuff that we did in the channel before, like the simple OpenOCD, JTAG and the UART, it's like too simple. We need to like step up from there.
On the soldering, BGA is something I'd like to learn as well. So maybe we could meet up at RevSpace at some point. And we have a BGA reballing kit at RevSpace. We have the hot air station, the preheater. We have all the kit. So we just and I have some old SODIMMs, so we can just experiment, desolder the SODIMM, reball it, and try it out in the computer, see if it still works.
Actually, someone from Twitter, Philippe from Twitter, Philippe Touwen, sent me a kit. Here it is. So a handwritten thing with.
Yeah, it disappears in your.
Oh yeah, okay. So I should show it here. Maybe I can zoom this. So I'm switching.
Oh, that's weird. On Zoom it disappears. On your Twitch it doesn't disappear.
Oh, okay. Oh yeah, I'm. Sorry. For my Twitch, I'm using a green screen, whereas for my Zoom, I'm using Zoom background fade.
Nice.
So I'm switching to the microscope, and now you still are. So
That's fine.
Okay. Now you're.
So, but you got mail. What did you get?
Yeah, I try to zoom into whatever I got. So this is
an Esd bag.
Yeah, but it contains very tiny BGA balls that are barely seeable and visible. And I got a piece of some wire and 2 circuit boards. So this is one circuit board, and this circuit board has some connections under the print. So there's some connections on the back as well. So what you need to do is get rid of the paint on top and use the wire to make connections to get one end to the other. So this is one CTF challenge, and this is the other one. So this is a circuit board that contains a chip, and so let's hold it the other way. So A135M4APACCUDK1F28A3. Have no clue. BGA is connected now to do something, but you need to rotate it to do something else.
Oh wow!
Yeah. So this requires reballing on 0.3 millimeters. So this was sent by Philippe. Really love it. But this is something that requires at least a microscope and some experience, or this will build some experience as well. So this is something that I want to do confidently after learning how BGA reballing works.
Cool.
Furthermore, I got a DM from New AE Technologies Inc., which is a company that creates a device called the Chip Whisperer. And this particular device comes with 2 parts. So one part is like a oscilloscope of some kind, and the other part is like a vulnerable device. Those are joined together, but the circuit board is perforated, so you can snap it in two and solder connectors to each other, so you can use it for something else as well. And you can use it for differential power analysis to see what the power uses is over time, to actually find out what the secrets are that are hidden into the device. But you can also use it to power glitch a device. And this is something that was like on my list for a very long time. Not to have it, but to understand it, because this is something I never went to university. Math stopped for me whenever letters were introduced. So I still have some stuff to keep up with whenever I. Sorry.
Yeah, the voltage glitching is extremely cool, and it's hard to comprehend. We had a workshop at RevSpace by Noobwafel with it. I couldn't get the software to work on my MacBook.
Yeah.
Because virtual machines are apparently too slow to reach USB, but it's it was a cool workshop, and I hope we at some point will be able to do it again. I can highly recommend it. It's nice to understand how to break stuff at a more analog level.
Yeah, absolutely. So what they told me is we are currently busy developing a commercial training, and we would like you to beta test this training. So nice. I got the training, and I was already excusing myself for not having enough knowledge to start this. And they say, no, we want you just to try it. We even sent you the hardware over, so you can. There's no excuse. You can just start it. And even the founder of this organization said, well, I'm the one that. Actually learned myself how to do it, so I like the path you're going and want to support you on learning new stuff. And I already finished the introduction in lesson 1, which is like the setting up the environment, but also the different techniques, and it all uses a Python framework. So it is a very, very cool environment that I have high expectations of. So I'm going to do this training, and I hope to bring back stuff to community as well. So not showing UART anymore, but being able to like facilitate information about power glitching to the community. That's like something that I want to give back. So furthermore, there was a release. So M5STACK was pushing devices like every day on RS485, on e-paper, and something that we're all were looking for was like this touch screen device, and we still don't know if the e-paper is touch screen. It's like, and they're not very clear about it. But this one was I'm showing it, and probably you won't see it via Zoom. But
but that's okay. I can watch it in time delay on the real. Wait a second. On your video stream, you're mainly showing a blue screen. Oh, now it's
sorry.
Cool.
This is
it's okay.
This is like the functionality of the device. So there's a couple of new things. I was not able to do anything with it yet, so it's still boxed. So what we now know, it's an ESP32 and it's a D0 WDQ6 V3.
That's nice. That's a new chip.
Yeah, and it has a few features that I really like. Like if you, I'm always fighting with the buttons of M5. So there's one button and you have to press it long or short, or have it pressed while starting. And this one, so let me unpack it, has 2 buttons. So you're not able to see it, so I have to raise this, and hopefully you are able to see it. Hold on. Yeah. So there's like a button on this side for power, and there's a button on the other side here for reset. So there's like two separate buttons, which make it really convenient for knowing what button to use for. So you're not like, do I need to hold it for a longer time? This is just one to turn it on, and the other one is the one
that's nice.
for resetting. So that's very nice. Plus the buttons are connected to the device itself. So the previous ones, like these ones, have a button which is a separate button. And if you ever taken one apart, I have the M5STACK since the early beginning, and I run into
one of those plasticky bits that flies away.
Yeah. You will lose it, and whenever you try to put the circuit board back into the casing, this will prevent you from doing so. So it's always a fight to get it back. So that's something that I found out. There's some other things that needs some focusing. So the screws are these are like the construction market screws, and these look very fancy. So it looks quite a bit better, like from a visual perspective. And under this board, and I might need a screwdriver. I have not opened it, but I've seen people open it.
Yeah, and they went with the ESP32 with the 8 megabytes of RAM, right?
Yeah.
I think I saw that. Cool.
So
that's literally the same chip and configuration as we're going to use for the MCH badge.
Yeah.
So that's nice.
Very cool. And shout out to Espressive for making these things possible.
Yeah.
So they put the extension on the board itself. So don't know what this is.
That's an accelerometer.
But what's this then? So yeah, maybe
that one is probably a compass or an accelerometer or something that detects rotation.
Yeah, at least that's what the signing says, and I don't know. This is 4R145W.
Well, with the hole in it. Oh, that could be a pressure sensor.
Ah, that figures. Yeah, cool. So this is on. Yeah.
Yeah, so you know your altitude and your direction. So that would be nice for your drone or something.
Yeah, very cool. So this is put on the back, and you can just put it back in. So they put down all the stuff on the board. So microphone, reset button, audio, I think I2S for audio.
Yeah, the ESP32 has a bunch of I2S devices on chip, so 2 or 3 I think. And they're great, not just for audio, mind you. You can use them, well, the CamSound badge use them for LED drivers.
Ah, cool.
To pump out data really fast.
Yeah.
It's just an incredible
I've actually
fast data pushing device.
Never worked with I2S. How does it relate to, like, for instance, SPI?
I have no idea. It's the kind of stuff I'm just like, oh, it's I2S here, I2S there. I make the purchase and then someone else makes it work.
Yeah, that's amazing. To have people around you that will figure that out. So let me see if I can turn it on somehow. Yeah, I have not enough distance to. Yeah, let's see what I can do. So power is on the left side. No, that's.
It makes sound.
Yeah, it makes sound, and
nice.
It has like this tricorder look. So there's like a spectrograph.
Nice little Star Trek UI.
Yeah.
Oh, it also does microphone.
Yeah, there's a microphone inside, but there's more with microphones. Like the Fire also had a microphone inside, but there is a vibration motor inside. So there's tactile feedback as well, which is very cool. And let's see. So you can do Wi-Fi scan. Maybe I need to remove this. So you see the networks that are around you with the strength. So you can go back. It's quite hard to see. It's like a timer. So if I turn.
Yeah, they made a nice little basic OS.
It looks good, cool. What I did, I have not seen. Not looked at any of the software, so there's an animation here which shows how the gyroscope is working. So the MPU 6886 will show in a box that you can tilt how it actually works, and the feel of the device. So. So stop. So one of the these. Okay, so and so there's motor driver. You can put the sound on and off. There's like a built-in factory test, so you can see if you have any dead pixels and if all the IOs are working. And I still need to look at the API to see what else is possible with this one. But I think they did very well on the UI. So from a user perspective, this is one of their best releases in my opinion. I really liked the Atom as well with the 5x5 because it has a lot of because you limit the functionality, and there was the same with the Camp Zone badge because you just have the 4x4 buttons. You're limited in your functions. This makes it easier to start programming for it, whereas for the SHA badge you have so much functionality and fonts and size and that it's harder to start. That's
actually always the balance. Every product designer, but also badge teams, have to figure out on how to make it as cool as possible, but still tone it down a bit and just have a bubble for the beginner to be in, and then after you're ready to breach the bubble, get more access to more cool features.
So the reason that we are together in this stream is that I was building boxes with sensors, as were you.
My boards are still underway.
Oh, okay. I saw you reaching. I was hoping like you show off your new board. So what's on the board?
So last week you mentioned that you want to make a matrix of M5 matrix, a matrix of M5 matrix devices.
Yeah.
So M5 matrix squared. I think you wanted the 4x4 matrix for your war driving efforts.
Yeah.
The 2.4 gigahertz range.
Yeah.
And then you said, but I would need to learn how to design a PCB and everything. And I was like, okay, we can do that together. That's easy. It should be easy enough. But then again, I've never taught anyone how to use Kicad, so I have not done many footprint designs and all that sort of stuff. But we're just gonna try and get to a point where we can maybe design a board.
Cool. Yeah, I went to the LTS and I designed circuit boards by hand, just using a marker, some copper boards, and then I get all the other residue off, and have to make my own jumps because it was a single layer board. I've seen the Opti board, I think Ulti board. What was the on the back of the Electure? There was this magical 1,700 euros expensive piece of software.
Yes, insanely expensive software.
Yeah.
Well, I didn't. Well, I went to a technical school. I never finished it, but not in electronics. I started out with learning Eagle first for PCB design, but their license model has become annoying. Besides being closed source, and there is an open source alternative, Kicad, which I still somewhat hate, but since I learned Kicad, I hate Eagle more, which is weird.
So what's the difference except for open source and closed source?
There is it's a different philosophy in how you approach designing a board. Eagle is very, for me at least, it was very flexible in doing something called forward-backward annotation. So if I place a component in the schematic, it immediately pops up on the PCB as well. And with Kicad, you have to take a few steps in between.
Okay.
Before it's there. Stuff like swapping pins, I felt was easier with Eagle. The main advantage I really love about Kicad is keyboard shortcuts.
Okay.
You can just hit a key, and you hardly have to do menu searches for finding a specific item. So in that case, that aspect, Kicad is a lot better than Eagle.
Okay.
But to each his own. There's nothing wrong per se with Eagle. It's I think there is a very limited free version still available, but all the cool kids are using Kicad these days. So if you're new to PCB design, just learn Kicad.
Okay.
Don't deal with the baggage I have to deal with.
Yeah, and just for reference, what's the price of the commercial version of Eagle?
That goes from a few €100 to a couple of thousands per year, probably. Okay. I'm not sure, I haven't checked.
Okay. Yeah, so that I know. And Kicad is open source, so works
open
on
source, free.
All the different OSs?
Yes, I'm now streaming this from my Mac.
Yeah.
So I'm running the Mac OS version, there's Linux versions, there's Windows versions, and they all work with similar performance levels. I'm using Kicad 5.1.6 apparently. There's also a nightly build available if you're adventurous. Some people find one specific nightly build that will actually function, and another moment you upgrade and then it crashes spectacularly. But there's a lot of cool stuff coming. It's being heavily funded by CERN, CERN in Switzerland, because they made a conscious choice of switching their entire operation over to open source.
Okay, well,
they needed a decent circuit board software for stuff at their level, which is about, well, if I am here, they are somewhere up there.
Creating large hidden colliders.
Yeah. So it's good stuff. There are some drawbacks. For instance, something really stupid. I like round traces, nice curvy traces.
Yeah.
Kicad at the moment doesn't support it. There are plugins for it, and there's other stuff you can mod with Kicad. You can run Python scripts on it. It's not there yet, but it's coming probably at some point in the future.
Yeah.
There is a heavy group of open source enthusiasts around Kicad doing tons of little scripts to make life easier for you. I'm using plain vanilla Kicad.
Okay.
Also for demonstration purposes, because it's easier to say, hey, just download Kicad and install it, instead of, oh, download Kicad, install this script, that script, toggle this setting, etc., etc.
Yeah.
So,
and one last question. How does it relate to the components that you use? Like, are hardware vendors supplying libraries that you can use to for your components, or do you have to make your own dimension and create your own library for the type of components that you use?
As with everything, both.
Okay. Okay.
There is a huge open source community out there that's constantly drawing up parts. If you're not using something really exotic, you'll probably be able to find it.
Yeah.
Let's try if there's an M5STACK Atom Kicad. Let's try if that footprint already exists. That would be cool, though.
Yeah. Yeah. Oh, wait a minute. PCB is already done as a sample.
Let's see. No, I can't really find a footprint, but we'll just make one and I'll publish it on the GitHub later tonight.
Cool.
It's easy enough. Oh, there's plenty of M5STACK breakouts. Let's see. Nah, it's more fun to do it ourselves anyway.
Okay, cool.
So let's just do that. So your basic idea of how you approach Kicad, and I'll start sharing my screen.
Yeah.
So that would be more useful. This is the second time I'm using Zoom, so
you're doing quite well.
If I'm skipping stuff, let's hit the share button. So when you enter Kicad, you get this little box.
Yeah.
And this is your main launcher, mainly for your applications. And it has a few tools in it. This is my project, the M5 Matrix project. And it already has, it automatically makes a PCB file and a schematic file, and then there's a bunch of buttons here that we're going to use. So the leftmost is the Schematic Editor. Then there's the, can you see the pop-ups? I'm not sure.
Yeah, Symbol Editor.
Yeah, this Zoom actually works. There's a bunch of streaming software that doesn't capture all the pop-ups. So the next one is the Symbol Editor, which we're going to use first, because we need to turn our M5 Atom into something we can use in the schematic and then in the board file. Yeah. PCB Editor, and then the Footprint Editor. The order of things for me is a bit reversed, but the Footprint Editor is what you that actually has all the dimensions, and this is a pad, and this is something you cannot use solder mask, and this is something you want copper or no copper, that sort of stuff. The Gerber button is there to view Gerber files.
What's a Gerber?
Production files. A Gerber file. Well, it's not a Gerber file. It's a set of files, and that is the production data. It's a plotter data the PCB companies use to make your boards. Yeah. So after you've designed your boards, you tell it to plot to Gerbers, or there's even a button that looks like a plotter. Yeah. And then you have a file format that's somewhat universally readable by PCB companies. Okay. It's universally readable because it's an ancient format. Okay.
And they're only using one? Only using the Gerber, or are there like multiple ways to go there?
Some companies accept Eagle or Kicad files. Okay. I recommend, because of sometimes version difference, that sort of stuff, just do Gerbers. It's
makes sense. Yeah.
It's just pushing 2 more buttons before you upload your file.
Yeah. And you're in control.
And you're a bit more in control, and you can check check it a little bit better. The next one is the bitmap to component converter. So if you want some art on your PCB, you can use this button.
Silkscreen.
Well, for instance, silkscreen, but also in copper.
Oh wow! Okay.
I can show you an example of that in a bit.
Yeah, cool.
And there's some PCB calculator and page data editor. I've never used them, so I'm not sure what they are. So. let's.
Will it keep track of the size of the lanes to take in account the current that's going through it, or do you have to calculate that yourself?
You probably you can set your tray sizes, and if you set the stuff up really properly, you can do an electrical rule check.
Okay.
Okay, this type of signal needs this type of track. I've never used that before because I'm way too lazy to set that all up.
Okay, but like the default setting works.
Yeah,
really high speed parallel stuff needs extra attention.
Yeah, especially. So when you've looked at a PC motherboard or a RAM module, there's all these squiggly little traces.
Yeah, to make them all the same length.
To make them all the same length and impedance and that sort of stuff. You can do that too, but that's something I never used. Oh, okay. Crazy is saying you need to move your mouse out of the frame.
Oh, sorry.
So I'm gonna switch to let's first try the symbol editor.
Thanks, Crazy. Yeah.
And I will need to reshare that specific screen. Let's see how that works. That should be this button. Okay, so this is the symbol editor. Because there's two things to a component. There's a symbol in a schematic.
Yeah.
And there's a component, a footprint in a PCB. You don't need to do a schematic. You can do a PCB entirely without a schematic. But for me, it's a lot more work. So let's try and design a new footprint. Now let's select. How do I do a new? I've never created a new symbol. Okay. What? Why is it asking me this? Can I just hit OK? Okay. Well, oh. I've removed the clicker from my scroll wheel, and it's now goes at lightning speed to do stuff. But let's try and make a symbol. So, if I can I please has new file, new library. Let's do that, and let's call it the M5STACK Atom Matrix. This is a save download, and I want it to my project.
Sneaking away to get myself one.
If I can find it now. M5STACK Atom Matrix, so here's my library, and then I can make a new symbol. And my symbol name is my Atom Matrix. And I can choose a reference designator, so I'm U, and there's 1 unit in the packet. So when you have one of those, for instance, those old logic chips where they had 4 NAND gates in a single chip,
yeah,
you can set the number of units. Create a symbol with alternate body style. No, boring stuff. I have no idea. Let's just see what happens. And I'm gonna make my screen a little bit bigger so I can actually work with it.
Yeah.
And I forgot one Kicad setting, so I can zoom in and out using my mouse wheel, which is also nice. Normal people have that. Mac users have to switch between using the touchpad for zoom and other stuff.
And there's a snap-on grid to...
Yeah, there's a little grid.
Oh yeah, cool.
You can hardly make it out probably, but it's there.
Yeah.
So and they have all these field references. So I'm going to move my Kicad is in Dutch.
Okay.
I think, but for the viewers at home will survive.
Yeah.
So I'm just I'll try and shout out the letters I'm pushing for keyboard shortcuts. So M is for move.
Yeah.
And then it asks you to clarify, are you sure you want to move this specific bit? Okay, so my little atom matrix has a bunch of pins. So
the U is for alignment?
The U is for U1, U2, so the IC1, IC2, like in the old electures.
Yeah.
So I'm going to add a pin.
Yeah.
And let's just do clickety-click, and let's give that pin a label and a number, and I have the data sheet. So this is my 3v3 pin, and that's pin number 1. I don't care. And it's voeding input, so power input.
Yeah.
And I can say tell it what type of symbol I want and other stuff. And I want it oriented to the right.
Yeah.
So that, and let's try it like this. So let's try another one.
But that's one.
Yeah, so I'm just going from top left to bottom left of the atom, viewed from the bottom. It doesn't really matter.
Oh, okay. So I thought like you put this on reverse and then it should be on the right.
Yeah, for now, for the schematic, it doesn't really
Okay,
matter. I
okay.
can just put them
Yeah.
all in one big blob and then
Yeah.
figure it out later on.
Okay, cool.
So the second one is G22.
Yep.
G22, and that's pin number 2 because it needs a name and it's a bidirectional thingamajig. Where did you? Oh, crap. Redo. Can I please house? I'll have to do it again. G22, I think I said. And it was pin 2 bidirectional. Click. Let's do number. So the next one is G19.
Yep.
And pin number 3. This is always a bit. This is the housekeeping. This is the boring stuff, but it'll be easy enough. So this was the 4th one, I think.
23 and 33.
G33.
So it's like
And that's
5 pins on the left
Pin 5.
and 4
Yeah.
on the right.
Well, you can. I mean, for a schematic, it doesn't really matter. So
Okay.
if you want to say, for instance, like have the power separate up here somewhere, or
Okay.
whatever you want, and have
Yeah.
all the GPIOs organized in a logical way,
Yeah.
you just can. So let's add some more pins. So we have G21, I think. G21, and that's pin 1, 2, 3, 5. So let's name it pin 6. For this one, it doesn't really matter. Normally, you want a logical order to stuff, but
Okay. Yeah.
G25, and that's pin 6 or 7 out of there. Let's see. Again, just disappears when I click on it. G25, pin 7, bidirectional, click. And then there were some more power pins because there's a 5-volt pin. But that's pin 8 for me. I'm going to call it power inputs. And I've got ground, which is pin 9. And let's also call it a power input. Or is there a separate ground thing? No. Let's call it also power input. So let's do some cleanup. I'm gonna move my 5-volt pin on top of the 3-volt pin. So I have it a little bit ranked.
Okay.
But this is all personal preference. It does not matter one bit for this entire project.
Okay.
Or for the schematic. For
So
that.
this is not the pin header alignment part.
No. Because we're gonna do that at a separate
Different
stage.
level. Okay. Yeah.
Yeah. So let's add a little rectangle, and let's just do. Let's see if this works. Ah, that looks really professional.
Absolutely.
Let's get a little bit more meat. Yeah.
Yeah.
I can work with this. Keep looking at the cursor at the wrong cursor that way. No, it's actually my cursor. Crazy. You're crazy.
Oh, this is the. No.
Okay, so I just saved it, and I think this should be good enough. Let's see what this button does. So you can get a table of. Is this pop-up coming up? Let me check. Does that work? Yeah, you can. So you can have an entire table of what is all in there in that chip.
Yeah.
In terms of inputs, outputs, and what state does it have.
Where did you get the schematic from? How did you know that those are bidirectional and not input or output?
Oh, I didn't.
Oh, okay,
I mean, the 5-volt, 3-volt, and ground are easy enough.
Yeah. Okay.
And the bidirectional, I just assumed, it's because G33 is the last GPIO on the ESP32 that's still bidirectional.
Okay.
I think. Okay, so we have this. Let's try and see the symbol properties of this. So there's also a pop-up called symbol properties. You can set your datasheet in there, or links to a datasheet. That sort of stuff. You can have just duplicate, no duplicate pins. I did it all right. Okay, so this one should be good enough, and I'm gonna close this window.
You don't have to save it?
I already saved it.
Oh, okay.
Button on the top left. So I now have a .library file in my Kicad project, and now I'm gonna draw up the footprint as well, because might as well do that too. And I'm gonna share the footprint editor with you guys. And a bit, let's see where it is. So this usually takes a little while to load the footprint editor. It's huge. No. It's already loading for 30 seconds. And here it is. Let's see if I can share that with you. No, it didn't change the zoom. How simplistic you are. Let's resize this window. Gonna try it again. Share screen. A nice big black screen. And I'm gonna draw up a new footprint. Oh, no, I'm not gonna use a generator. Can you? Oh, I didn't hit the share button, sorry.
Well, I was just blaming Zoom.
So let's see what this. Oh, kill some windows. Okay, I'm gonna draw up a new footprint, and let's call it the M5 Atom Matrix.
And footprint is the dimensions of the device and the...
Yeah, it's literally everything you want happening to the circuit board.
Okay.
So in terms of drilling holes, laying down copper, laying down
space required,
through holes, keep out zones, everything, silk screen, everything can be done in here.
Yeah.
So what you see here on your right hand side is the layer manager.
Yeah.
And it's probably a little bit tiny.
No, I can see it. FCU, BCU.
My window a little bit so it's a little bit better readable. So you have FCU, BCU, front copper, CU is for copper, BCU, front and back, adhesive, back adhesive, front paste, back paste, front silk, back silk.
What's adhesive and paste?
Okay, so if you have components that need to be glued down before you solder them, so that's the adhesive layer.
Yeah.
The paste layer is where you, for your solder stencil, you make the apertures.
Yeah.
Because sometimes on a footprint, when you have a pad that's, for instance, square pad, you want a little bit of adjustment in the paste dispensing to make it flow better.
Yeah.
There's tons of science behind it. I've never ever looked into that. Front mask and back mask, that's keep out stuff for copper, I think. DWG's user is drawings for you, so your notes basically.
Okay. That will not be printed.
No.
Okay.
And there's some other stuff that won't be printed. Courtyards and fabrication stuff. All stuff we're not going to use now.
Okay.
Basically. So I have another little grid. In the top I can set it to whatever grid I want. I've now set it to a 5 mils grid. A mil is not a millimeter. A mil is 1/1000th of an inch. So a 1 mil grid is 0.0254 millimeter.
Okay.
everything in basic electronic stuff is designed on a thousandth of an inch grid.
Okay.
So I'm going to set it to a, let's see, that's what's useful. So these are all these pins are at a standard distance of 2.5 millimeters, 2.54 millimeters. So I'm going to set a grid for half of that, so I have some wiggle room to place them.
Mm-hmm.
So 1.27 millimeters.
And you typed it in manually?
No, there's a pop-up here at the top.
Oh, okay, yeah, I see it.
And again, the M is for move, so I'm going to move my M5 reference a little bit up. I have no idea yet how this is all going to work, but let's just try. And let's just start with drawing a pad. So this green circle with a hole in it, add pad.
It's an aisle, yeah.
And let's, in Dutch, an eilandje.
Yeah.
I just dropped it down and I'm going to edit it because I'm not sure what it does. Oh, sorry, I hit the E, I hovered my mouse above it,
yeah.
Then I hit the E button for edit, then I get the little pop-up.
Yeah.
And then I can set all sorts of stuff I want for this pad.
We don't see a pop-up.
Oh, crap. Let's share that one because that's actually interesting. Where did my zoom go? You are screen sharing, new share. Let's share that window. That actually makes a lot more sense. Let's see if this works. Is it sharing? No, it does not capture. I'm very sorry.
I see pad voorkeuren.
Oh, you do. Oh, the I was watching the Twitch stream, which is always a minute behind.
Yeah.
Okay. So here I can say, okay, pad number. I can say a net name. I can set all sorts of stuff up. But now, for now, I'm just going to label it 1, and it's a through hole pad. I can also set it to SMD, so it becomes a part that's a pad that's only on the top.
Yeah.
Or connector, or non-plated through hole, NPTH, a mechanical hole, so just a drill.
Ah, okay, like for alignment for stencils.
Yeah, or maybe just a drill hole, like for your screw in the back of your M5STACK.
Ah, yeah.
That sort of stuff.
Yeah.
But for now, I'm just going to do a through hole, and I can set circular, oval, rectangular, trapezium, rounded rectangle, whatever. I'm just going to go with circular, and I'm just going to go with all the standard settings. So 1.5 millimeter size, and there is somewhere, the hole size, how big the drill hole is. You can also set up. You can customize the heck out of this if you want. For now, for this one, it doesn't really matter.
Default pins.
So, yeah. So I'm gonna zoom in a bit so I can actually see it happening, and then I'm gonna duplicate it. Let's see if I need to go back to the other window. Just give me a second.
Yeah.
That's always the annoying bit with these video calls, that you're not always aware of what everyone else is seeing.
Yeah.
Okay. So I'm gonna hit. If you're a Linux user, it's probably Control D. I'm gonna hit Command D because I'm on a Mac. No, you don't want to? Oh, you do. So I'm gonna
duplicate.
Just duplicate these pads. I'm not sure why it's not. Oh, that's what was wrong. I was on the wrong layer.
Ah.
But they're all now labeled pin 1, which is not really making any sense. So I'm just gonna delete all of them again. And I'm gonna do it by hand. So pin 2, pin 3, pin 4, pin 5. And now the tricky bit is how much spacing is there between the left and the right half. So I'm gonna.
I can get a pin header.
Yeah, I've already tried figuring that out.
Ah, okay.
It's if I recall, it was 15 millimeters, so about six or 7 holes in between. So I'm just gonna cheat and gonna add some holes to the bottom. I will delete later on, just for alignment sake, so I know what I'm doing. I think it's, let me get a board so I can count.
I have it on the camera. So there's 1, 2, 3, 4, 5 in between.
5 in between.
Yeah.
So now there's 3 in between, so I'm not doing enough, but I'm selecting them. I'm hitting M for move. And now I have 4 in between, and now I have 5 in between.
Yeah.
So that should be good. So all these can go. So now I have basically done the most important bit, which is drawing these holes.
Yeah.
We do need to make some connections to, which I have not figured out yet. How am I going to link it up to a symbol at some point? Oh crap, did I in fact do the...
Hey Joseph.
Let me check if I numbered all the pins correctly in my schematic bit, because that will matter at this point. So the pin number I used in my schematic symbol should be the same pin I'm using in my drawing here.
Yeah.
And yes, I messed it up, which is cool. So I'm going to change these. So pin 9 is not actually pin 9, it's 1, 2, 3, 4, so it's G21, and G21 I connected to pin 6. And then this one is G25, that should be pin 7. So I just did them the wrong way around. So
Okay.
Just edit them and change it all up. And this is the 5-volt pin, which should be pin 8. And then this should be pin 9. I could have just moved them around too. So this is my basic.
No, it's correct, Crazy. We can see the editing of there's like two different screens.
Yeah, to keep sharing the pop-up takes longer than actually doing the stuff. So for this one, you missed it. Sorry.
Yeah.
Now we need to draw the outside as well.
Yeah. So the outside is at least 1 pin extra on the left, right side and bottom side.
I'm just using this, if you don't mind.
Which one?
A caliper.
Ah, okay, yeah.
I'm just gonna use a caliper. Yeah, that was the property window again, Crazy. So the M5 is, if I am going to draw it, I want to draw it at 24.5 millimeters. So 245 instead of 254. So should be. Let's just try and make a nice little drawing on the silk screen layer, because that is where it's supposed to go. You can also, let's do this better. I know a better way. I'm gonna start up Inkscape. Let's do this the nice way, because we can have nice things in Kicad. I am going to share my Inkscape screen.
Already excited.
So here is Inkscape. If you can see it.
Yeah, I can see it.
Okay, I'm just going to do one boring bit and then I'm already done.
What's in Inkscape? Is that part of
Inkscape? No, Inkscape is another open source tool.
Okay.
It's a very, very good vector drawing program.
It's like
the old Coral Draw.
Ah, okay, yeah, love it.
So I'm just gonna draw a square.
Yeah.
Boring little square, and I'm gonna set it to. I set 245 to 24.5 millimeters, and the height as well, 24.5. And I'm gonna
curvy.
Yeah, I'm just gonna give it that little bit of curve.
Yeah.
Because, as I said, we can have nice things.
Beautiful.
So that looks better, doesn't it?
Yeah, it's. I see an M5STACK Atom already.
So, and Yes, normally you want to set the exact curve and that sort of stuff, but
Yeah.
let's keep it simple. I'm gonna rescale my page so it's a nice compact file. You can't see all the dialogue I'm doing now. I'm just gonna, there is a save function and that can save it to
SVG?
Dxf.
Oh,
No,
okay.
in this case not, Dxf in
Yeah.
this case.
Which stands for?
It's some Autodesk
okay, yeah. Clear.
AutoCAD format.
Yeah.
I'm not entirely sure where my file is supposed to go, but I can just set it to the desktop. And then let's call it the M5 maybe. M5.dxf.
And
So
I
you
have
can't see all the dialogue, but it was just a save dialogue
Yeah.
with some boring settings. So
people can try this at home.
yeah, and then I'm gonna in my menu I'm gonna import outline from Dxf file. So it's not that advanced. It can just do basic outlines, that sort of stuff. But it's good enough for us in this case.
Can you
So
do
I've got
fancy bitmap to
Oh,
vector?
I need crap. I forgot one step because I forgot to share my screen again.
Okay.
So I'm gonna back to the footprint editor. And
Yeah.
you're again not able to see my dialog, and I want you to see this dialog because this helps.
Okay.
Let's try it better. Import outlines from Dxf file, and then I should be able to just share this tiny little dialog. If it actually pops up somewhere. No, it doesn't want to.
Maybe
show you this.
external screen and share a screen instead of a program?
Yeah. Then the problem then becomes this is a 4K screen. And I'm just
okay.
using,
Yeah.
About 10% of it, and then you'll be unable to read anything.
Yeah.
So
Okay.
you'll just
Ne-
have to
never
trust
mind.
me that I'm opening the M5STACK, and
Yeah.
then you can set the layer, and I'm setting the layer to front silk.
Yeah.
And I'm going to set a line width of 0.1 millimeter and an import scale of 1.
Yeah.
So my file was already in millimeters. That's important because Kicad wants to work in millimeters.
Mm-hmm.
So, and here is my little M5 thingamajig.
Yeah. Now the alignment. So the alignment should.
You could actually see the graphics pop up, the import pop up. Cool.
Yeah. We could. Yeah. Sorry.
Okay, so I'll just drop it in and then I'll align the pins from there. So I'm just going to center this on the center-ish. So I now have this beautiful little square.
But
The pins are all in the wrong position. I know.
Okay.
I'm also making a critical error because we're viewing this from the top, so from the display side. So the right hand, the left hand side of the pins need to be swapped.
Yeah, true.
Let's do that first.
Okay.
So, and now I forgot my alignment in between. It was 5 pins.
Five pins
right?
in between. Yeah.
Let's try it. 1, 2, 3, 4. Nope, not enough. So I need to move. Drop one more in. Yeah, so 5 in between. So that works again. So let's use the calipers again and set the bottom alignment. So the first one should begin at 4. Wow. Tongue at the right angle. Let's see, 4 point. Yeah, I cheated anyway, so I'm just going to set it at 5 millimeters from the bottom. So I'm going to use it.
It should have the same distance from both ends, from both sides, as from the bottom.
Yeah, that we can do. I should be able to just.
Yeah, if you align it to the middle.
Yeah, I'm hoping.
First grouping, maybe.
Yeah, I don't remember if this supports a grouping.
Okay.
So we're just gonna have a look through the dialogues for a second. No, of course we can't. Why should we be able to have nice things? But let's just be rough about it. It doesn't really matter because it's the other stuff is silkscreen. So if I'm in the ballpark, so 3 dots to the left, 3 dots to the right.
1 up.
And now it's 2. That should be good.
Yeah.
And I can even just zoom out and then hold my M5STACK to my screen.
Yeah.
It's not actually that bad.
No, it looks just fine.
It looks the part.
Yeah.
Okay, so
I've heard of people printing it and then testing it with pin headers.
Yes, you should.
Okay.
This is the kind of stuff you want. You always want to print out your PCB on a piece of paper and just fit your components on there to see if you actually got everything right.
Yeah.
Kicad has an amazing 3D preview. But it makes sense to just what am I doing wrong?
Cannot have space. They're using
no library specified. Oh crap! I need to specify a library where it needs to go. Oh, I need to drop it in a specific library. Oh, why can't I just? Let's see if I can just new library. M5 Matrix, project based, and then if I can save it to the library. So it's a little bit of work to get this done right.
Yeah, but I think this is cooler because you now already see that you can make your own stuff and like really specific stuff.
Yeah.
So this is not just adding a component, it's just adding an entire product, a new product to the device.
Yeah.
To the library. Yeah.
I feel like I'm still doing something wrong because it's not saving in this specific. Here we go. Just looking for this dialog. M5 Matrix. So now in my M5 Matrix library, there is an M5 Atom Matrix part.
Yeah.
So that should be good. Okay, it's saved. I'm going to close this one, and I'm going to close my symbol editor. And now we finally are ready to start our schematic editor. And I'm going to share that screen with you. And
yeah,
here we go. We get a nice piece of drafting paper.
Yeah, cool.
And this is actually just something for you, for reference. The software doesn't need it, and your paper is actually as big as you want,
yeah.
I think.
Okay.
There's also tricks to have multiple sheets and have them interconnect with each other, which is very, very cool. And then you can reuse bits of your schematic in other projects as well. So,
okay.
For the Camp Zone team has already perfected this, so they have a separate sheet with all the ESP32 and all the specific pull-up resistors and pull-down resistors it needs to boot.
Yeah.
And then they have a sheet with all the USB serial stuff that's always standard on every batch, so it's easier to just get going.
Yeah.
So here we are, and I'm going to zoom in a bit, and I'm going to press the A button for add. Then I get a nice little pop-up.
We don't see the pop-up.
What?
But doesn't matter. No, cannot.
Okay, sorry about that. It asks me what type of component I want, so I'm going to use my M5.
Okay.
See if it comes up. M5 Atom Matrix. There is my M5 Atom Matrix symbol.
Yeah.
And here you go.
And this is what we designed like at the start.
Yeah, this is the schematic symbol we designed. So.
And why has the U in question? Question mark?
Yeah, the U is the designator, which we settled on early, like R.
R and a C, and yeah.
Yeah, but we haven't told the software yet to give it a number. We're going to do that in a little bit. But first, we're going to draw some.
If you have more
bits.
Yeah.
Yeah. So let's give this one power.
Yeah.
So we're gonna do a 5-volt rail, I assume.
Yeah, that's like the second thing. Like I lack the background in creating a power circuit for this one, so I do not want to power them all individually. So I think the best way is using the 5-volt, as there is like a power regulator to it. But how can you dimension?
Yeah, let's do that. So first off, I'm just gonna tell it. It's gonna connect to 5 volts.
Okay.
So I'm just gonna hit A again. I'm typing in 5V, and then I'm getting a nice plus 5 volts.
Okay.
Symbol.
Yeah.
And it's not connected yet. It's just 2 separate bits now. And I'm gonna do the same with the ground. So I'm gonna search for G and D, and I'm gonna put it close by.
Okay.
Doesn't really matter. Okay, so now and I can move these around with the M, just like last time.
Yeah.
So I want to wire these up, so I'm going to hit the W for wire.
Yeah.
I'm just going to drag and hit the W to close again.
Cool.
So W and then W to close. So now it's connected to...
The joints are green.
Yeah, the wires are green.
Yeah.
So now it's connected to both the 5-volt and the ground rail. There's nothing else in the schematic, so it's not connected to anything at all. But if other bits have that flag as well, then they'll all become interconnected.
Yeah.
So let's add another M5 atom matrix. I'm just going to copy this one. I'm going to hit C for copy.
Okay. Can't you just copy the entire thing with the power rail as well, or?
Probably. Let's try. If you select a group, it automatically wants to move. So
okay.
Yes, it should be able to, but I haven't figured out why.
Yeah.
It doesn't work.
Clear.
So just gonna do another set, and if you ever make a boo-boo while clicking and it's still open the command, just hit escape a few times, so it defaults back to the normal cursor.
Okay.
You can always escape back out.
Yeah.
My mouse wheel went crazy again. So now these two M5 stacks are actually connected through their power rails.
Yeah.
You also said you wanted a data bus between them.
Yeah. So as it is going to be a bus, I2C looked like the weapon of choice.
Yeah, sure.
Or do you have other suggestions to do so?
I have literally no idea, because this is... we can just try I2C. So any preference to pins?
If you look at the bottom, their pins of choice are G26 and G32.
Yeah, those two are broken out on the Grove connector, not on the back panel.
They should be.
Did they duplicate?
No, they do not. Sorry.
No. So, but the thing is, the ESP32 is really flexible in terms of pin choice for their hardware devices.
Yeah.
So you can just choose any pin, and that I will. So so there's two ways of doing this. We can do this the ugly way, and we can do this the pretty way. I'm going to show you both. The ugly way is just say, hey, I want a wire between G25 and G25. That's the ugly way.
Yeah.
I'm going to delete those because there's a nicer way. I'm going to add labels. And there's two types here. There's a net label and a global label.
Okay.
I like the shape of the global labels, but it doesn't really matter. There's also a hierarchical label, which is for those multiple sheets. We're not going to use those. So I'll just use a net label. So I'm going to place a label around G21. Let's call it I2C SDA.
Yeah.
And rotate it twice. So the R is for rotate.
Okay, yeah.
And place it nice and close to G21. And I'm going to do another one with I2C SCL.
Yeah.
Change the alignment. So now I have these two nice little labels, and if I wire them up to my pin, those pins become connected to the SDA and the SCL bus.
Yeah.
There is no bus yet, but
yeah.
So now I'm going to copy these over, So yes, you can probably automate this, and you can even do this with a nice little Python script. This is just a demonstration.
Yeah.
So now I have two M5s, both with the same I2C pins connected, 6
Yeah.
and 7. Maybe you want something else like an interrupt pin.
Yeah, I was thinking about it, like having an interrupt pin as well.
We can do that. We can always add that in later.
Yeah.
And you want something to get power to it. What do you say about a USB-C connector?
Will that be able to host the power for 16 atoms?
How much power does an atom draw?
That should be in the datasheet, or at least on the website. So let me see.
I mean, if it's not broadcasting, it should. If it's just listening to Wi-Fi, it should just be a few milliamps, right?
Yeah, but there's LEDs on it as well.
Oh yeah, but LEDs, come on, it's overrated. They're not that bright.
Sorry?
They're not that bright.
No, and
you set them that bright. If you overpower the LEDs on the M5 stack, the glass melts.
Okay.
There's a specific warning in there from do not set the LEDs above this level because they'll melt.
Yeah.
Yes.
Oh, nice one, Joseph. Yeah. If you share the power rail, they will all boot at the same time, and there will be a search.
Yeah. Okay. Well, let's just pretend this will all be fine, and we can add some capacitors to the power plane as well. We can do some trickery. So let's just try a USB-C connector, and if this doesn't work, we can always figure out something else. So add USB Type-C receptacle for USB 2.0, which is ridiculous because all the M5 stacks already have USB-C.
Yeah.
Oh, I'm just figuring out, thinking of what we could do is if we set it, so it's 16 you want, right?
Yeah.
So what we could do is set it up in groups of 8 or groups of 4.
Yeah.
And then have a separate USB-C power cable for each group. So you just plug it each into its own power bank or something.
Yeah. Okay.
But let's just keep it simple for now. So add this one in. If it's USB-C, we need 2 resistors as well for on the CC lines, else it won't give you power. So I'm going to add. Then hit R for resistor, and I'm going to set a value to it of 5.1K or
and
5K1.
This is to indicate the power that it will supply?
Yeah, without it, it won't give you the full USB 2 power.
Okay.
So let's duplicate that one by copying it. And if I recall, I need to pull them to ground. Let me check that. Where can I check that easily? I think I need to pull them to ground. I'm not entirely sure, but I think so. Yeah, let's pull them to ground. So I'm going to add my 5 volt symbol. I'm going to add my ground symbol. And I'm going to add my ground for my okay, and I'm going to wire these up. I'm going to wire up my 5 volts. So we now have a USB-C connector with some resistors. We're not sure what package there or whatever is. Nothing has been set yet. We're just set. Okay, we want some resistors there. And we want 2 M5 stacks, and we all want them connected like this. Okay. Let's just. I'm just going to do 2 more of them, so we have 4 of them, and then so we have the mini matrix, and then we can always try and go with more. Oh, duplicate block. Oh, you can. Nice. Okay. Let's try that again. No. Okay, you want me to actually select it all. Okay. Duplicate block. So now we have 4 of them.
Yeah.
And we can always just let's duplicate some more. And now we have 8 of them.
Yeah.
It's like that Mickey Mouse cartoon when he axes the broomstick.
Yeah, yeah.
Here's exponential growth for you kids. And duplicate. Oh, lo and behold, we now have 16 of them.
Yeah.
All connected on the same bus, so this will become a giant mess, but we'll figure that out later. So, next step. We're asking about all the question marks. So I'm gonna hit a few buttons here in series. So the first one is annotate, and then I'm gonna assign footprints, and then I'm gonna switch to my board.
Okay.
So annotate, it tells it to basically give each part a number.
Okay.
Just gonna hit annotate. Yep. I don't know if you didn't see the pop-up, but you will see the result.
Yeah, see it.
So they are all nice and accounted for. So the next part, and this one I will try and share with you because this is important. Let's see, the assign footprints thingamajig.
Yeah, see it.
Seeing it?
Yeah,
You're
we see it.
it. Cool. So here in the middle, this is a bit weird. This is a weird interface. Just to let you know. In the middle is our symbols.
Yeah.
So all our parts. Also the value or something that's assigned to it, so we know what it is.
Yeah.
And to the right is a filter for footprints, and to the left are our libraries. So I'm gonna go to the Atom Matrix, and to the left I'm gonna go with M5 Matrix, and then I'm gonna assign by double clicking.
Oh, okay.
It doesn't like my double clicking. I missed a few.
So for the resistors you probably need a packet size.
Yeah, so I'm gonna do that too.
And the USB-C
connector. Yeah, so for the USB-C connector it's easy because there's one type that will work. That's this one, the C31M12. It's cheap and it's nice and it's easy to solder. For the resistors, I'm gonna make it easy on you. I'm gonna select 805 resistors.
Okay.
Let's see, resistor SMD, where are you? Each second. Resistor SMD.
Yeah.
And then I'm gonna select, and here is a tricky bit because there is metric sizes next to it.
Yeah.
So 603 metric is 0201 real size, and it's incredibly tiny. So we're going with 805. And I'm gonna choose the hand solder pads because they're a little bit bigger.
Okay. For both of them.
And then hit apply, save, schematic, and continue. And then it closed that window. So now the final button I'm going to push, I'm not going to show you, but it's the button to go to the PCB.
We see you now.
Yeah, that's fine. I'm going to share my screen in a bit.
Yeah.
So I'm now switching over to the PCB Design software. And no, I don't need to share my entire screen. I just need to share PCB new. And here you go. Here is our circuit board. Well, there isn't a circuit board yet, but here's our circuit board.
Yeah. Will be our circuit board.
Yeah, so it's again one of those nice little drafting sheets which doesn't mean anything except that it looks cool.
Yeah.
I'm gonna hit this button which shows both a schematic and a PCB and a little arrow in between. It's the wizard to import stuff from the schematic to our board.
Okay.
I'm gonna keep all the default settings, just hit update PCB. And when you hit those, you see all our bits.
Wow.
And you can drop them anywhere. I'm just going to drop them off in a corner. And now the real fun begins because it now needs to become a PCB.
Yeah. But I think this is already cool that it is able to convert a circuit design to a PCB.
Yeah. Yeah. So what this is now showing you is all the footprints, and it's showing you all the nets, all the connections between the things. I'm not entirely sure where all the blue lines are coming from, but we'll see. So I'm gonna move, oh, that was it. It was because it was still selected. So let's move this out of the way, the USB-C port, and let's first just order some matrices. Well, they're all connected the same way, so it doesn't really matter in which order I'm doing stuff. So I'm just gonna move the ones that are, no, let go. And I think we need to give them a little bit more wiggle room, but I'll do that in a minute. First I'm gonna set up a matrix of 4x4.
And is it like some recalculation, or is it automatically being applied?
Oh, what you're seeing all the nets jumping around,
yeah.
The white lines jumping out. It's calculating the shortest distance between one of the same net.
So is it multiple layer? Because I see lines through other lines?
No, there is no layers yet. This is just the white lines are just connections. There is no copper yet.
Okay.
We haven't drawn that yet. It's just to explain to you that, hey, you need to do something.
Yeah.
So I'm going to show you something cool. I'm going to show you the 3D preview already. I'm going to hit Alt 3. I think I need to hit Option 3 in my case. And I'm going to switch that over to you. I'm going to hit the button.
Wow.
And this is a 3D preview of what we're doing so far.
Yeah.
So it's actually starting to look like a PCB already. It's a bit, they cut off right at the edge of where the parts are because it doesn't know yet where the edge of the board is. 4 switches. Oh yeah. Crazy is suggesting doing 4 separate power rails by using physical switches. Maybe. But I think the USB-C connector should be able to do this anyway. But we can add that in and just make it optional. So in the bottom is our USB-C connector and some our resistor, little resistors and the entire design. Well, I'm gonna do some more PCB work for you. I'm gonna share that. Let's see, PCB, and hit share, and here we are again. Next time we do one of this, I'll just get a separate computer and just capture the video output so I can just show it full screen and not have to deal with the constant switching anymore.
I think sharing Kicad was still on your to-do list, right?
Yep. So I'm gonna set up a grid of, let's see, let's do a 10 mil grid. Yeah, 10 mils is fine. I'm gonna move. No, I don't want all of you, I just want one. No, it doesn't really snap to grid, but I can just do that by eye. It won't be perfectly aligned, but it will be aligned enough. Just gonna give it a little bit. Oh, I can use the alignment tool anyway, so.
Distribute evenly or that kind of stuff.
Yeah, that sort of stuff.
Yeah.
Gonna try one of those tricks and see if it.
So now it will have some separation in between.
Just to give you a little bit of room if you want to pull one out or whatever.
Otherwise you won't be able to get one in between out.
Yeah.
Or what you could do is like make holes underneath so you can push them out from the bottom. But I think it is still a good idea.
That's a nice idea actually. That's a good idea. We can do that at any point, so we can just add that.
But I think from the radio perspective, it's also good to give him some space.
Yeah. So the top ones are now nicely aligned. So let's move these. And then let's set their height. Okay, and then, oh wait, if I do all the vertical alignment first, yeah, I know how I'm going to approach this. So let's grab you guys, align to top, move. Alignment is always a little bit tricky, but I think I have an idea of what I'm gonna do. So I'm gonna align these distribute these so they're all nicely spaced.
Yeah.
So now my top horizontal row is nicely spaced. My leftmost vertical row is nicely spaced. That's all open. I think I forgot one thing. Are they all aligned to the left? They weren't. Ha! So now they're all nice, so I can just do this, and I'm not entirely sure if it's... Yeah, it's aligned to the right of the last one you select.
Yeah, it's the same with PowerPoint. It's always a guess which one they take.
Align to the right. Ah, this is becoming
pretty. This is looking so cool. I was not expecting it to be taking place or that fast. Like, yeah, the amount of time that it took you to get to this point. Yeah.
Mm-hmm.
Really amazed.
Well, you're asking for a relatively simple board.
Yeah, this is something that I could do on a experiment PCB as well, with the pin headers and the stuff as well. But this would be like a perfect first example, like soldering some pin headers and maybe some special thing. Yeah, this is doable. Okay. This is, you can even make people happy with these boards.
Yeah. So let's try and figure out. Joseph had a nice idea about, or crazy, I'm not sure, crazy it was about
the switches.
We can solve this problem. Oh, I know how to fix this. How about in your software just say, hey, push the button to activate the Wi-Fi.
Yeah, you could.
That should just work.
Yeah, there's just a button in the device itself.
Yeah, it's a button.
Yeah, it is a button.
So
yeah, it's like the tactile feedback. So
if this doesn't work, I mean, PCBs are really cheap. So if this doesn't work, we can just spin a new one and figure it out from there.
Yeah, I've been approached by a couple of PCB vendors, like choose me.
Yeah, you're famous now, right?
yeah. Don't start the influencer stuff. been there, done that.
you know, I'm just teasing you.
Yeah, I know. So, but like,
it's not a bad thing.
No, like, depending on what you do, if you like a retweet cannon on Twitter and just unverified information. Creation.
The main thing I want in my video streams, I can endorse products. I don't want to be an exclusive brand whore. For
no, same, yeah.
And
I want to have an honest opinion about it. So if I hate it, I should be able to say that I hate it.
Okay. In the meantime, I was just moving stuff around.
Cool. Looks good.
The resistors for the USB-C connector.
Yeah.
So when we're building this board, let's just I can't show you. I need to switch over if I want to show you this in 3D. I'll just keep in 2D.
Yeah.
So if we're soldering this board, I would recommend doing the tiny stuff first, the two resistors and the USB-C connector, because those are always a bit harder to do, and then all the pin headers. But you're plugging in the M5s anyway, so it doesn't really
the USB-C, is that like pin through a hole for the connection?
No, it's for the USB part. It's SMD.
Yeah.
Rather tiny ones as well, but it's still doable.
Yeah.
And through a hole for the.
Yeah. To make them firm on the PCB, so you cannot take off the entire.
These connectors are awesome. They're a lot stronger than the previous micro USB connectors.
Yeah, love it.
Always ripped off boards.
Yeah.
Well, at least I did.
Yeah, me too.
So let's start routing some power. So you were asking about trace width. You can set your trace size is here. It's now at 0.25 millimeters, so we can just make a really thick one of 0.5 millimeters, and let's do a 0.75 as well. I'm not sure if I need it, but I can just set it. And let's see if this, So
that's in millimeters.
Yeah.
Okay.
Yeah, Kicad has to do this weird balance between
mils and millimeter.
Yeah.
Okay.
So let's first do the USB CC lines, because those are hard and will always get in the way. And I'm actually gonna move stuff around because I want those power traces nice and outside. Oh, this one connects to the one on the right. I'm gonna move this one to the left. So this is just power, no data over this anyway. So they're nice and center.
Can we add a power switch to it?
We could.
Will it be harder?
No, it won't be any harder. It's just finding the thing always with parts is
the proper component.
Knowing the component and the footprint that matches it. For tonight, to save time, we're just just gonna do this because it's already 9:45. And I know you need your beauty sleep at some point. So we're gonna hit the. This is nice. We're gonna hit the X for exciting mode.
Yeah.
Because we're actually gonna do stuff, and then I'm gonna wire up. So hit X once to get started. Hit X when you're done for the other end. And I already set up the 2 CC lines. Yeah. So it now knows where it's going. Hey.
How do you see that it's a CC line?
I know it.
Oh, okay.
It's not on here, but I could in the schematic label it.
Yeah. Okay.
But for now it's fine.
Yeah.
And now we have to set up the power rails, and I'm gonna do that right now. Let's take a nice and thick 5-volt rail. Let's see if that will actually route. No, it's too big. It won't go.
Next to the resistor.
It doesn't want to go. But I can
otherwise the pad will be
Yeah. So I'm gonna do a nice loop around. I'll fix those for the resistors in a minute.
Okay.
I'm just gonna do a nice loop around here. I'm going to drag it up a bit so I have a bit more room. So I have a nice thick power trace I can just start routing up.
Yeah.
But now my ground pads are isolated.
Yeah.
So that's annoying. So I'm going to go to the thinner mode because these are just 2 boring resistors. I'm going to connect these 2 together, and I'm going to hit the V for via. Go to the other side of the board.
Ah, nice.
I'm going to go to one of my ground elements, or just go to this pad because it's also connected to ground.
Okay.
Done. That problem is sorted.
Cool.
And I also need, and now I'm gonna do all the 5-volt tracks, and I'm gonna give them really thick track. So because here I have plenty of room, so I can probably do the 0.75. Yeah, I'm on the wrong side. Hit V, and I can just do all the looping around. I'm gonna connect it up later, but let's first all join them all together.
Wow, looks beautiful.
Oh. Yeah, Kicad does do some stuff logically. Not all of it, but a lot.
Yeah.
So I'm gonna just meander upwards. So there's 2 layers now. Yes, there's 2 layers of copper, the top and the bottom side. You can also do a 4-layer or 6-layer board. Whatever you please. The more layers, the more complex and the more cost.
Yeah, and the harder the rework.
Yes, you cannot reach center layers when you need to rework. So you need to really think about what you're gonna do with your layers if you're doing center layers.
Yeah.
Actually, on the Hacker Hotel 2020 badge, there is stuff hidden in the middle layer. So I'm hoping that at some point someone will grab an X-ray and figure out the hidden messages.
That's so cool.
if you don't want to grab an X-ray, just get the Kicad files, but it's more fun to use an X-ray. So I now have
You only have it on one side. Is there any sense to make it on two sides? So it is redundant, but
okay. If you're doing heavy motor drivers, that sort of stuff, really
LED drivers,
But this, let's just assume that each of your tiny things takes up 400 milliamps at best, and that's really worst case for an ESP32. So that would be maybe 2 or 3 amps if they're all worst case. Doing that consecutively. This trace will be big enough.
Yeah, cool. Okay.
But you can. There's plenty of examples doing that.
Just wondering what was best practice for doing so.
I have no idea about best practices. I'm nowhere near best practice. I am my own worst enemy when it comes to PCB design. So let's do the ground trace as well. So I'm not for this board, because all the M5 stacks are doing Wi-Fi stuff.
Yeah.
I'm not doing a ground plane.
No, I was thinking about that. That was not a good idea.
That will cause problems later on. So let's not do that.
You make it directional though.
Yeah. Impractical and directional.
Yes.
Now I'm stuck here.
That's good. Wow,
I can just do bottom traces too, right?
Yeah. I know. No, I love this way. Yeah. Oh, but we're going to have some. Like the I2C needs to be done, so
the I2C can go on the bottom board.
That's
not a problem at all.
Actually, cool.
And I need a bottom trace here as well, or
no, not even. You can.
No, I do. Yeah, I'm stuck now. I can go all the way around. Yeah, I can go all the way around.
Via the other one. Oh, okay.
I mean, I need to connect these. I need to connect these anyways.
Yeah. Okay. Love it.
That's all fine. And here I need a thinner trace, else it won't root. Let's get a nice and thin one. This one. Fake it until you make it.
Yeah.
Go through the USB, Crazy said. Yes, I just did. Time delay is interesting.
Well, this is a bit better than the earlier Periscope version where you had to wait 1.5 minutes.
So let's just do the 3D view again, because that's cool. Hit new share, hit 3D viewer, hit share. So now you see our 3D view has changed a bit because all our traces are already there.
Yeah.
And if I flip it to the other side, there's just that one little trace I made earlier.
Yeah, cool.
So, if I wanted, I could make a model of the M5 stack, or if we have one, a step file, we can just add it as well. Just have it on there. I might actually do that. Let's go back to our PCB and add the USB-C connector as well. I like the 3D preview because it really gives you a sense of what you're doing.
The U's are through the other ones because of the distance. Is that something that's...
Sorry, what?
U as a indication for the device are overlapping on the other devices. So
in the silk screen.
Yeah, in the silk screen.
Like this, yeah. We can move that around. You can just go in, just grab one.
Oh, and move it. Okay.
Yeah, but
we see you now, right?
Yeah. Oh, sorry.
Okay.
Yep, I forgot.
No.
Click.
Normally Crazy is reminding me on switching views, but
yeah. So we have one here, and we can just hit M for move.
Yeah.
Hey, oh, I need to duplicate. And then I can just say reference U1, and I can move it over. But to be fair, I normally just hide these references.
Oh, okay,
I just go here, I just go to properties, make them invisible.
Yeah.
But whatever suits you.
Yeah, it doesn't really matter.
I2C.
Yeah.
Now we need I2C.
Yeah.
Let's do that in nice and somewhat thinner tracks. So I'm going to set it to 2.25 because those can go nicely in between. That looks good. I'm interested to know if we can actually pull this off with I2C because it's 16 devices on a bus.
Yeah.
That's it's capable of it, but it doesn't really like it. And maybe we need the pull-up resistors as well, but I'm not sure.
Yeah. Yeah, I think that depends on what you're going to do with the I2C bus. So my idea about the I2C bus is make all the devices do their own stuff and like synchronize over I2C instead of doing all the stuff entirely over I2C.
Okay, well, you're the software genius, so
I don't know.
I'm just gonna leave that up to you.
We'll see about that.
What we can do is that we just add the footprints for some pull-ups.
Yeah.
So you can change it up.
Yeah. What is the like 4.7 or?
Anything you want.
Okay.
It depends on the speed you want and some other variables. So I'm not sure which one to choose. Okay. It also depends on the number of devices and echo on the bus and some other stuff.
Yeah, that's like the background knowledge that I lack. But
yeah, me too.
So it looks very cool. When I had two ESPs on board, I use Serial because it has a hardware buffer. Serial would probably be a bad idea for 16 ESPs though. There is USART, I don't know if it supports it, but that has like a bus feature as well.
Yeah. So I'm gonna go
Vias?
Through the ground, through the bottom plane.
Yeah.
So just hit V1, so now I have green traces on the other end. Do we want it to go? I think we need to go as a bus. So let's do it left and right.
Yeah.
Linked.
Almost one wire.
Yeah, I don't think I2C appreciates star topology.
No.
So let's do it like this. I'm not entirely sure, but it's probably for the best. So I promised you some more resistors, so let's do that now.
Yeah.
Just gonna pop back into the schematic, hit screen sharing. Here's the choose symbol dialog, so I can show you that. Now you can see my symbol picture.
Yeah.
And I hit R for resistor. And then the window closed. And I can just place that and share. Well, I'm just going to connect it up and save time. Sorry.
That's perfect.
It's easy. It was a pull-up resistor, so I'm just going to add 5 volts to both. No, not 5 volts, right? It's a 3 volt bus, so I should not add 5 volts to it. I need to add a 3 volt bus. Else stuff will burn. And we don't want that, do we?
5 volt bus, 3 volt bus? Tell me.
You don't want a 5 volt pull up on your 3 volt bus.
Ah, okay, you were connecting it to the 5 volt, okay.
Yeah.
We don't see any screen, is what Crazy is telling
Yeah,
me.
yes, I know. I just did it really fast because I wanted to be done with it. Just gonna add some footprints and then I'm gonna go back into the PCB.
Yeah.
So just bear with me for just 1 second.
He's already telling, okay. I was not expecting this to be so awesome, but I really enjoy this. Like I was like,
okay.
I'm canceling this. I'm heading to bed. But yeah, this is really energizing.
Okay, so here we go. We're back at our PCB, and I've added my 2 little resistors.
Yeah.
So I'm gonna find a nice little spot for them close by, somewhere where we're not in the way of everything. I don't want it. Oh, I can just flip them to the other side, right? I can just I can put them on the bottom.
Yeah, good.
So I'm just gonna select them. I'm gonna hit F for flip. So now you
nice.
see their paths change to green.
Yeah.
Gonna move them in the direction of my I2C. Oh, I didn't connect them to the I2C. Nice. Just a second. Be right with you.
Yeah.
I connected them to ground, so it's now just an energy waster. Let's copy SCBA and let's copy SCL. Hit save on my schematic.
Oh, that's a good one as well. Joseph is telling why not have a pin header on the side for I2C and ground
for debugging.
For debugging and connecting a logic analyzer. Yeah.
Yeah, we should. You're a fan of the Grove platform, right? So
Oh, Grove. Wow.
Let's just add a Grove connected to
wow.
it. That's easy enough. So first I'm going to set these up, and then let's see, where's the 3.3 volts anyway on this thing?
No, we only have 5 volts.
I forgot another bit. One more clickety-click on my schematic. I need to add to one of my M5 stacks U1. Which one is in this corner? Because I want to connect to this one specifically. U4, I think. No, not U4.
It's on the opposite side of the ground, so like diagonal.
I know what pin it is.
Okay.
It's just I'm missing the. I'm looking to find a U12. That was the reference I was missing. So let's find U12 in my schematic. Where did I put you? U12. Let's add a 3 volt free label. So this is a bit of cheating, what I'm doing now. I'm just connecting that one 3.3 volt device. Update here. Oh wait, I'll zoom out and I'll make you see what I just did. So when I hit the update button, you should be able to see one extra wire coming up here. Update PCB.
Okay.
And there we go. I'm still sharing the screen, right?
Yeah, you are.
Yeah, cool. Nice.
There's no wire, just a line.
Yeah, that's what I meant.
Yeah, okay.
So I'm gonna put these nice and snug to my I2C rail because, hey, we probably won't need them, but if we do, we can just add them in.
Yep.
And then I'm gonna hit exciting mode. And I'm gonna connect these all up. So these are done.
Yeah. And these are 805s as well?
Yeah.
Okay.
So basic 805s, and let's just add a bit of text for them so we know what we're doing, and we're placing that on the bottom silk. So that's I2C pull up 2 times 4K7 probably. Yep. Maybe 10K, maybe 2K, but you can experiment.
Yeah.
So I'm just gonna drop that here, so you know why we did that.
Yep.
So if we, I think we're at that point where we need to make a board edge, make an outline, make it give it a shape.
Where's Nicolette when you need her?
Oh, I can. Did you see that little?
Yeah, I saw it. It was epic.
That little snake.
Yeah.
Just add that in.
Snack. Yeah.
Yeah, I can just add that in. That's easy. That's we made that a component. So I'm just going to measure. I'm just going to measure from left to right how big my board is, how big my stuff is already, and do that same with top to bottom. Oh wait.
Yeah, and include the connector as well.
Yeah. But
Okay.
this is just a measurement, so let's just go here. We can always. I will intend to give it a bit more dimension. So it's 121 in height at least and 108 in width.
Over 10 centimeters. Balen.
Yeah, it doesn't cost. It doesn't cost that much more.
No.
It's.
I'd rather have a proper one than a cheap one.
Yeah, well, you could make it a bit more narrow. You can plug the USB-C connector
on the bottom. Yeah.
So yes, you could fit it in 10 by 10 if you wanted to, but
Yeah.
Well, tell me if you want to, if you want me to. I can probably squeeze it in, but I think it's a bit more
like
a bit nicer aesthetically.
Yeah, aesthetically and heat distribution and radio wise. So I would say like have some separation between the devices. Yeah. Maybe add the holes to it at some point.
Oh crap! And I already popped all these traces in the way.
Yeah, but it can be on the top, right? Doesn't not necessarily have to be in the middle.
Yeah, true. On the other hand, you probably won't need it because you can just. I think you can just grab one or use one of those old IC.
IC pullers. Yeah.
And you can just grab it and pull it out. So I think we can do without if you're okay with that.
Yeah, we can do without. You're right.
Okay, so let's set a width of 115 and a height of 125, I think. 115, 125. So I'm going to go back into Inkscape. And I'll share my screen because I'm nice like that. Inkscape.
And if we can add some holes to the side, so you can pull a cord through, mount it somewhere
sure.
to position it.
Yes, that makes sense. So let's make it a little bit bigger than that I just said. Can I zoom in? Come on. Don't be a tease. Come on. You can. So I was saying in my Kicad, I said I need at least 110 for the devices, and then we need to add some holes. So 130, yeah, 130 is fine. Why is you not working? It does not like me.
Yeah.
It's doing weird stuff. It's probably the
previous
probably the old file that was conflicting with Zoom.
Okay.
So now it's behaving. So 130 wide.
Yeah.
And let's make it. I can do 130 by 130. So
yeah, that's cool. Yeah,
around.
Then you have like a big M5.
So let's give it those nice signature rounded corners because we need those. Yeah, and I can add the holes in later. So I'm gonna export this as set the page size first. Now it looks the part. Opslaan. And let's call it M5 Matrix.dxf. I've exported it. Now I'm going to switch over to my Kicad board again. Go, share.
How long does it take to get a circuit board to the Netherlands? So like depending on the shipping that you pay, probably.
Mostly shipping, yes. I suspect you could have it on screen within 2 weeks.
Okay.
1 or 2 weeks.
Yeah.
I'm gonna open my file M5 matrix.dxf. I'm gonna import this to. I'll try and drag this in the picture. I'm not sure if you can see it.
Yeah, we can see it.
I'm gonna import this to the layer called edge.cuts.
Okay.
Which is literally here. Please cut here.
Yeah.
And here is our board outline.
Oh, perfect.
And let's set it up to the edge of the USB-C and try and align it a little bit in the middle. Probably this. Okay, let me check. Yeah, that's perfect.
Very cool.
Okay, so now we've got our board edge. Let's hit the 3D button again, and I'll show you. New share, 3D, share.
Wow.
And this is what our board looks like now.
Wow, 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 wow.
So we have now 16 of these bad boys.
Yeah.
M5 needs to send you a box of them. Please, M5, sponsor this project. We want to see this actually work.
I think I already have 4, so yeah.
Yeah. I have a few as well, so we can probably populate it a bit.
Yeah.
But this is, this
cool.
is the part.
Cool.
So you wanted something added? You wanted a...
Yeah, Grove connector for tapping into...
Yeah, so while you look up the pinout to Grove, I'll look up, I'll start editing the schematic.
So what I'm doing is I'm just obtaining one of the sensors of M5STACK, and this is a, what is it, humidity environmental sensor, and
yeah, it's a 1x4, it's a 4-row connector, right?
Yeah, it's 4-row connector,
and it's it's a male connector, yeah, so that's a 1x40, 1x04. So 1x4 connector male. Let's add that. Oh, slow down, cowboy.
So with the notch on the top, the left is the ground.
Yeah. Oh wait, I've got a Grove board in front of me. So ground, VCC, SDA, SCL.
Yeah.
And the VCC is for 3.3, right? On the M5STACKs.
No, it's 5 actually. But we're not using VCC.
Well, you might, but I'll bring out.
Oh, we can do the 5 volt, and you can actually power it over Grove.
That could also be an option, yeah. Let's add the 2 connections. So it was 5 volts and ground, right? No,
the other way around.
Exactly opposite. Nice. And that would cause burnage.
Oh, Crazy says tricky if you hook up a device with 5 volt pull-ups.
Yeah, that shouldn't be much of a problem though. It should be okay. So now we need SDA. And now we need SCL as well. So it's SDA SCL.
Yeah.
So. And I think this should be it. Okay, so that's it in the schematic. I'm going to annotate it. And I'm going to add a footprint to it. And that's hard because it's a JST at 2 millimeters, if I recall correctly.
Is it 2 millimeters?
It's not 2.54.
Yeah, it's 2 millimeters. Yeah, correct.
So let's do a nice horizontal. I'm going to show. No, I'm just going to connect it and be done with it. Let's do JSTPH horizontal. That's the nicest. In the meantime, I'm getting tons of emails from work for some reason. So give me 1 second to kill Outlook. Because I don't need work emails at Saturday night. Okay, so I have this, I have my footprint, so I'm going to go back to my board. I'm going to take you back as well. Share. And I'm going to hit update, and my connector has arrived. I'm just going to add that in at the edge as well, like the USB-C, because that looks nice. And let's root it out. Let me first check if this actually matches what I'm looking at right now. And it does, it works. This is good. So I'm going to wire it up with the exciting mode. I'm going to start at the bottom first.
So are you adding the snack to it to the side, or?
We'll figure out a spot together.
Okay, because otherwise might be an idea to have some symmetry and have one connector on one side and one on the other, maybe.
Oh, okay. So move the growth connector a lot more to the right hand side.
Yeah.
And have it centered with the. Oh, yeah, sure. Not a problem. Everybody has a different design aesthetic in this sort of thing, so fine. Let's move. It's easy enough. I didn't root any traces yet. It actually makes my life easier, I think. Exciting mode. No, I don't want that. I want this one first.
So how did you see that this was the SDA or SCL?
That's the fun bit. It already does that automatically.
Oh, it snaps to the correct one.
Yeah, it just highlights the one.
Ah, with the white line. Yeah, okay, yeah. Now I see it.
So it just clicks and it can just help me out.
Yeah.
And I need some power traces as well. I'm going to make them a little bit bigger than the...
Have them bent your way.
Yeah, a little bit.
Yeah.
That's better. So let's do a 3D preview again. Let's see what happens. Screen sharing to the 3D. And some components already have 3D models.
Oh, wow, 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 wow. Yeah.
So that's relatively simple. Let's go back to our board. Share screen, go back to Pcb new. So we now have a USB-C connector for power. We have a growth connector for going expanding to a second board of M5STACKs, whatever.
Have a panel of 256 M5STACks.
Yeah. And, so plenty of stuff.
Oh, I did forget something.
What did you forget?
So yeah, introducing extra complexity. But this actually won't fit on the board. But we could also use this one for the GPS.
Oh, okay. I can't see it because it's...
Oh yeah, that's I2C. No, this is RFID. Rats. So hold on. GPS. Oh, but that needs different connection.
Yeah, that needs serial probably.
That needs serial, yeah.
Okay. Well, the thing is, I don't think you actually need GPS. I'll tell you why. There is this Bertrick of RefSpace wrote a little bit of software.
Yeah.
That pinpoints your location based on available Wi-Fi signals in the area.
Yeah.
So might not be needed after all, but I'm thinking if you use this like sort of your Wi-Fi scanning antenna over I2C and have one master controller through the growth connector.
Even have a multiple,
Have that one be the GPS sensor as well and the data logger.
Yeah, and I could use one of the growth connectors of the M5STACK that are on the bottom, so the one in between the two connectors, actually to connect two GPSs to have redundant GPS.
Yeah, sure. I think what we need now is some holes.
Yeah.
So I'm going to add those as well. I'm gonna do that the nice way by adding them to the schematic which is a bit weird, but you need to add holes to the schematic first. Is M4 enough?
Yeah, that's fine.
Or M3?
No, rather have M4 because then I'm able to pull a rope in them. It's not for like positioning them with screws, but more like for mounting them or holding them on a like wearing them.
Okay. I'm just gonna add 4 mounting holes to my schematic, annotating them, and now I need to select a footprint, and you can't see it, I know.
Yeah.
So 4mm M4.
Yeah.
It's big though. You might want 3mm M3.
Okay. Do M3 then. If you think M3 is better,
M3 is big enough.
Okay.
You can lift a house with M3.
Okay.
So I'm gonna add these in by my update button, and here are click. Hey, where did you? So here are my 4 holes.
Okay.
And I'm gonna move them into. I don't need to move one. No, I don't need to move the reference. I need to move the hole. I'm just gonna do a bit
of distance.
Bit of YOLO alignment.
Yeah. So Joseph is saying the only proper way is an M5 one. Joke.
Yes. I wanted to, but then I was like,
nah.
I'm not granting you the satisfaction. Let's see.
No, it's a great joke. Yeah.
Okay. So here's
cool.
Our mounting holes. Let's do a 3D preview to see what it looks like. And I'll click. I need to have some buttons for that. On board with mounting holes as well.
Yeah.
So what I would do if I were ordering this for production is remove all those ugly references I'm not needing.
Yeah.
Like this one. That sort of stuff. But other than that, I think
it's done.
I think this will work.
Yeah.
Okay, let's try and get it ready for. I'll share my PCB screen again and try and see if JLC PCB or another PCB company can accept the files. So let's just say for now we're happy with it. I'm not entirely, but I'm happy enough with it. And I want a quote. I'm just going to use. So here's in the top left there is the plotter button next to the printer. There's the plotter.
Yeah.
Looks like one of those old-fashioned ones.
I've used with those. Yeah.
Let's see if you get the pop-up.
No.
Pop-up. No, I'll share that separately because that's actually useful. Here you go.
Okay.
So to the left, you can select all the layers you want exported.
Yeah.
For now, I just need front copper, back copper. The paste layers are useful for a solder stencil if you need one. We don't need one for this project. Front silk and back silk, so you can print on the front and the back layers. And mask is for the solder mask, so where do you want the green stuff or the black stuff to cover your copper?
Yeah.
And edge cuts is the board edge.
Yeah.
So I'm just gonna set a directory where I want this. And yes, and I'm gonna add the Gerbers. I'm just gonna hit generate drill files. I'll generate a drill file separately and I'll hit plot. And that's it. I now have a directory and I'll, where is Finder? Where did I actually put all my M5STACK files? I have no idea. Let me look up where I put my stuff. Oh wow, I put a project inside a project. Useful. Really, really smart. That will fuck up Git in a moment. I'll move that on later. Let's go to my documents. I'm not sharing my main desktop with you, sorry, but I'll get to the zip file, then I'll show you what happens from there. So, when you plot your Gerber files, you get a bunch of files, .gbr.
Yeah.
M5 Matrix, M5 Matrix, Gerbers, and you just zip them all up. And I'll get a nice and clean browser.
We still see the plot window, right?
Yeah, I know.
Okay,
I'll
do whatever you have to do.
I'm switching over in a second. Where is? It doesn't get it. So let's share my browser. Let's go on Safari. Just to aggravate all the people who hate any other browser than Chromium, here is Safari. And I'm gonna hit, when you reach JLC PCB, you don't need to fill in any of this crap on the front, just hit quote now. And you add your Gerber file. Let's see where it went. It went in my documents. Yeah, fuck navigating on the Mac. It's sometimes so hard to find your stuff. Kicad. I dumped it in my batch radio project accidentally. Let's go. Gerbers. Archive.zip. Here we go. So it's now processing our Gerbers, finding out how big it is and what layers are on there, that sort of stuff.
Yeah.
So it detected the 2-layer board of 130 by 130. There's a preview, so you can check if it's done all right. I didn't add the snake yet, so I'll do that too. You can set I want how many boards you want. So we want 5 boards. That's the minimum.
Okay.
You can add stuff like panelizing. If you're doing a small board with a stencil, you can make it a panel, so it's multiple boards on one panel. For some.
Oh, you can snap them off, or.
Yeah, you can just break them off.
Okay. Yeah.
You're going to set your PCB thickness. Don't change it because it'll become more expensive.
Okay.
You can't if you need to. There's other colors available which will cause a bit of a slowdown, but it probably looks better in black, or in blue, or in red, or in yellow, whatever you want. You can make it HASL Hazel with lead, or lead-free, or ENIC, which is gold cover.
Okay.
For this project, I don't recommend using the gold. It adds about 20 euros, so let's not do that.
Okay.
And the thickness of the copper, also boring for this project. We don't need any gold fingers. We don't need any flying probe test. All that sort of stuff is on there. But for now, it is just enough. So it would cost you €7.51 for 5 boards.
Yeah.
And then €8.57 for a Euro packet.
Yeah.
The fun part about the Euro packet, especially when you're doing a little bit bigger orders, when you're going above the VAT amount, it's already paid. They pay it in advance.
Oh, okay.
And it's DHL shipped to your house, so not DHL Express, but the normal DHL. So it gets here relatively fast.
Yeah.
Especially if you order a green PCB, you should have your board within 10 days.
Yeah. Really cool, really fast.
Yeah. So we needed to change some things. We needed to add the snake. Let's stop this share. Let's go back to our PCB. And we had some cleanup to do, and then I'll just push it to a Git, and you can download it and order it if you want.
Cool. Will do.
I need to open.
So if you push it to Git, will it include like all the components that you have, or do I need to have like libraries?
I automatically include the libraries. I did do. Why is this not here?
I'm back in 5. Hold on. You just continue.
Oh, okay. Yeah, let's do the cleanup first. I can't find the snake right now. I'm just gonna bluff because Gillis isn't listening. I'm gonna edit all those little. Oh wait, we can do that automatically. We can hide these designators. I'm just gonna bluff and hope Gillis doesn't notice that I didn't add the snake because I have no idea where I put it. Let's just keep that our little secret, okay? Oh, wrong. This one, edit. Oh, shit. I need to press OK. Let's zoom in here and clean this up a bit. No, I don't need it. I don't need it to tell me this is a USB-C designator. Let's see, edit, this one gone. Edit, this one gone. Let's see, there's now more. So let's add a little bit of description here because we want to know that it's 5.2 times 5.1K 0805, and we want that on the front silk. But that's not front silk, that's back silk. This is front silk. But let's put it a little bit hidden underneath that M5 stack. That's better. Stop. Let's clear out some more. Yellis is still moving around, so he's still not noticing that I'm not putting on the snake. Okay, just do them.
And I'm back.
Cool. Oi, welcome back.
Thank you. Put an Easter egg in while he's not looking. Cool.
Well, I didn't see the chat, but I was just I was just teasing people.
Okay.
We want the snack. Yes, I want the snack too, but I can't find the file at the moment, so I'm not sure where I put it. But I'm cleaning up the rest of the crap. And the fun part about Kicad is that this PCB file is all text files. So you could just, instead of doing this by hand, by clicking each and every single designator, like I'm doing right now because I'm stupid.
Parsing it with set.
You can just open up the text file and just use search and replace if you're a modern human being, or use set and do the old school hacker way.
Okay.
And that really works well. I edited footprints for my USB-C ESP32 board.
Yeah.
Using that, and that saved me hours and hours of manual labor.
Yeah, I can imagine. It's like what Jure did with the logo of the void warranty sticker, to swap the colors using the SVG file.
Yeah, that sort of stuff. That's
mounting hole.
Yeah. Yeah, the white text doesn't appear on silk screen, so that's fine. Yeah. So this is pretty nice. Let's see how it looks in.
Crazy is asking, are you deleting the references or moving them to another layer?
No, I'm just turning them invisible. You can delete them, but that will cause problems if you ever want to undelete them. It will cause mayhem.
Yeah.
So. Okay, so that's all nice and clean. So let's give this board a little bit of more text. So I've hidden here Yillis on the front silk screen. Let me show you. Oh, this is now on the back. Let's put it on the front. It needs to be on the front. There's the resistor value of these two resistors.
Ah, okay.
When you add the M5 stack on top of it, you won't see it anymore.
Yeah, understand.
That's stuff I like.
Yeah.
Let's add some text to describe this project. Yillis's M5 Matrix.
Inception. And let's
put it on the front too.
The Matrix. The Wi-Fi detector. That's on the back, right?
Yeah, I know. I have no idea where it's.
Okay.
Yeah, but now it's on the wrong layer, so I need to put it back on front silk again. No idea why it's doing it in reverse.
Crazy saying M5 Matrix square.
Yeah, that's not that. It's actually nicer. Let's see. I'll just steal that square symbol from you, Crazy, because I have no idea how to type it on a Mac. It's probably easy, but
Yeah.
this is nicer. Let's see if the software. Oh, it does. It does. Alt-GR+2. Yeah, probably.
Remove the inception. That was just a joke. I like the M5 square.
Okay.
Matrix. Yeah.
Let's make this a little bit bigger.
Yeah. Love it.
Let's put it up here.
Alt-GR2 is what I read. Yeah.
Yeah, it probably does, but it's
Alt-GR. There's no Alt-GR on Mac. It's like option
no,
command.
We have option.
Yeah.
But it's probably something like command option something
Yeah.
that I don't care.
Yeah.
It's okay.
Yeah, works.
Yeah, this is nice.
Yeah. Can we align the holes to be on the same horizontal line?
Oh fuck! Did I didn't, right? Let me check. Oh yeah, they're misaligned. You're right.
That's like for.
Yeah, but just to make your life easier.
Yeah.
That's better, and let's do the other two as well. And then I need to align this one to this one. Wow! You were right. Well spotted. Yeah, that's better.
Yeah.
It's not perfect. I mean, it's not in the perfect square sense.
It does not matter, but as long as they are horizontal and vertical aligned, then it will.
Yeah. And it's like the fun part about this is you can just export something like a PDF and then just chuck it in the laser cutter to have your holes drilled in a piece of wood if you want to.
Yeah. Cool.
Okay, so let's save this. Let's plot some new Gerbers. And in a bit I'll just add it to my GitHub so you can have at it.
Yeah.
So I think this is complete, or did we need to add more features? I'm lost a little bit in what we were doing. Do we need to add more? I'll show you a 3D preview of where we are now because it's looking cool with the silk screen. New share.
The Grove spin through hole, right?
Yeah.
Okay, cool.
Yeah, it's a standard JST pad.
Yeah,
and if you want the SMD version,
no. I rather have the pin through hole, like for firmness.
Mechanic.
Yeah.
Yeah, that looks cool.
It looks very cool.
Can I let me just give me 1 second if I can find a 3D render of the M5 Atom. I'm going to go to grabcat.com and let's log in. Let's see if I can find something M5 library. If I can find it, I'll make a preview with the M5. Oh, then it's showing all these kinds of stuff with M5 holes in them. M5 Atom. There is one!
Oh, the excitement coming off the stream! Oh, this is... I love it, yeah.
This is gonna be funny.
Yeah.
It's gonna be funny. You're gonna like this one.
Yeah.
So let's...
I like it already.
Let's add that file to our folder. Let's... I need to go back to my board thingy. Let's figure out how to edit that. Add that to our thingamajig. 3D settings. Let's add a file. Click. I don't need this. I need to go to users, to my notifications, to my documents, to my Kicad junk folder, to my badge radio because I dumped it there, to my M5 Matrix, to my M5 Matrix, And then there is
Pretty.
the ST,
Oh.
the step 5 file. Let's see where it is. M5 atom.step. There we go.
Wow!
Okay, so now we need to
rotate it. Yeah.
To rotate it a bit, but that's easy enough. I first want to see.
Oh! Oh, this is so cool!
Let me just check if I got the right. Yeah, it's the right side up.
Yeah.
Okay, and it's now we can also see that our measurements were correct.
Oh, but then we need
Also,
pin headers too.
No.
No, this is.
So
this is
let me just check if I did it for all files now, or it just did the one. Oh crap. Let me think how I'm gonna do that fast, but I'll share you a 3D preview because it's funny to see. Well, you can have a look at that while I add all the.
Lovely, 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 lovely.
Okay, so I am thinking of doing a little bit of text file editing jiggery pokery because it's way faster. Oh, it doesn't want to. No, come on, don't be a bitch. I need to close my PCB. Oh shit, it also closed my preview. But hey, I can also share my text editor with you so you can see my reasoning. Misclicking. I don't need my PCB editor, I need my text editor. Come on, you're a Mac, you can do text edits. Okay, let's
Crazy is telling we want to see the hacking. Lead hacks already. Already has his hoodie on. Can we have green letters on black screen as well?
No. Let's. Can I should be able to zoom in, right? Come on. Plus. Yeah.
Yeah, it was already readable.
Yeah, but for me.
Oh, okay.
it's a 4K display.
Okay, yeah.
So let's find my step file. So .step. Where is it? So here is my model line. So I need to inject this into the other bits, I think. Let me have a look at another matrix that doesn't have it. When it closes off. Yeah, so it's just adding these lines into all M5 matrices. Okay, let's try that out. It's not the easiest way of doing things probably, but we have time.
Yeah.
Click, plak. Klikken en plakken. This will either break everything or make this really work.
The curly bracket at the end, is there like an opening for it? Oh, that's model. It's parentheses.
It's parentheses, but it's...
Okay, yeah, it's opening and closing, okay.
We'll just see what happens.
Yeah.
And if stuff breaks, we can always unbreak things.
Yeah.
That's why I normally, when I'm doing Kicad stuff, I just make a Git repository. And
you get all back.
And you commit every 5 minutes or so, because else you will hurt yourself.
Yeah.
Git early, Git often.
Yeah.
Oh, I needed to add a return. Probably not needed because it's probably just stupid text files. But this one's already done.
Thank you so much for this epic Kicad training. I really like it.
Command S, okay. I saved it. Let's open the project again. Let's open the Kicad file. It still loads, so let's hit the preview. Oh.
We only see you smiling. Bring it on, man! Bring it! Oh! Let me take a snapshot of this. This is so epic.
So I'm gonna add in the USB-C connector as well because I have a model for that too.
Yeah.
So just give me a second. Let me find it.
Oh, Cray said add the USB-C.
Yeah, I'm working on it. Let me see where I put it. And I need to move it into its... Oh, that's scale, that's not what I... Oh, come on. I need to rotate... No, I don't need to rotate it, I need to move it. Move. 4.5 millimeters, and then I need to move it forward. That's better. And there you go.
Oh, beautiful, beautiful.
Yeah, this really makes it this is what I like, because now I'm using these 3D previews not just for aesthetics.
Yeah.
But just being able to judge if you can build it.
Yeah.
It's like, oh, this tolerance is a bit it's a bit tight to hand solder.
Yeah. Yeah.
So here is your M5 Matrix squared.
I never expected to be like in one stream. Wow, wow. Oh my god, this looks beautiful. Would never expect something like this.
Yeah, so now we need to get M5 to send you 16 of these buckets. They will send you 16 of these. Yes, I know they will. Just to see this crazy project come into fruition.
Yeah.
But yeah, this is one done board.
Yeah.
In fact, I think the USB-C connector might not even be needed, because each M5 stack already has one. It shares the 5 volt power to the outside. But it's probably better to do it this way.
Yeah. Yeah, it looks more neat.
Yeah.
Yeah. Cool. I'm so... Joe said I'll be a beta tester. I'll pay for the PCB if you send me 16 atoms. I think you should be a beta tester, Joseph. Being like that experience with wiggling around. Cool. Thank you so much for this epic episode of one of the videos that you do. Yeah, I'm really a big fan of you. Like from a management perspective on handling the hackerspace, from like soldering, from batch team. Actually, I was a little bit scared of you, like for doing I have to admit, like maybe scared is the wrong word, but like intimidated by your capabilities. So I really want to show off at Camp Zone with the hardware hacking workshop and show off that I was capable of doing stuff myself too. And yeah.
Don't underestimate yourself. You're doing stuff way cooler than I'm doing. But that's always you're always impressed by stuff other people do, and you always downplay your own skills.
Yeah, that's true. That's true. But like this collaboration, I love it, man. I really love it. Yeah.
This is one crazy. And I reckon. So before we actually send this into production, I recommend you. I mean, you have a few of these lying around, right?
I have a few of these lying around. Yeah.
Just test out if you can have them communicate on the same bus, like this, and we can always change it up if you want.
Yeah, maybe add a interrupt channel somehow.
Something.
I think I have at least four or five lying around.
Yeah, so that. Yeah, I'm digging this perspective view.
Yeah.
So M5 Stack, if you're listening, they are not, but they should send you 16 of these.
Okay.
To make this happen.
I
this
can
will also be the most epic Wi-Fi deauthenticator.
Yeah. 16 channels at a time, people. But we don't have 16 Wi-Fi channels. Doesn't matter.
It's like, hey, I'm seeing activity on this channel. Boop.
Yeah, yeah. The entire idea for using you can use this board for a light version if you don't want to spend that much money. Actually, it's not that much more expensive, but you could use lights and you don't have the interaction on the boards. But the cool thing by using matrices is that you can already show colored lights, like 25 for each atom, to show how many Wi-Fi networks you found on a specific channel. So you immediately see like 2 on 2, 3 on 5, 12 on 10.
Yeah. One thing we did design the most expensive 20 by 20 RGB matrix.
Yeah, that's true. That's true. and you know what? Nobody cares.
Nobody cares. No. It's like this board, this 13 by 13 board contains roughly the equivalent of 16 Pentium 2 computers. I mean,
yeah, like the compute power and like the stuff that you can do with it, like both from a Wi-Fi perspective, like from a red team perspective, from a blue team perspective, from Bluetooth perspective, like your ultimate COVID counter, it's endless. It's endless.
Yeah, I recommend we redesign it to 8x8 and make it an M5 chessboard.
Yeah, and you could even like position from one device to another, like hit a king and move it like a front or whatever. Yeah.
You know what this looks like? Have you seen those pictures of Chinese like farms where they have 20 cell phones in a rack or 2,000 cell phones?
Oh yeah, absolutely, yeah. I've seen like people hanging the phones for the Uber close to a building to be like, choose me, I'm your designated driver as my cell phone is hanging in the tree next to your company.
Oh, wow. Jesus Christ.
Yeah.
But this is a nice little board. You can even, I mean, if you're interested in doing like stuff like statistics and you want like each statistic on its own little display and its own little button, it's actually not that bad for LED buttons in terms of price, especially if you do it in bulk. Yeah.
This has so many opportunities, like cool.
Nice project.
I can already tell you, like, some of the tweets I send out, I think this is like really important and people will really embrace it. And it's like, I have 2 likes, and I showed off my Raspberry Pi stack, which I really don't care about. It's just a bunch of Raspberry Pis on top of each other, and it like exploded with 1,000 retweets. People really dig clusters nowadays. So having such a device, setting up clustering with ESP32s or whatever, people really dig this.
Mm-hmm.
This will explode, I can tell you. So I will send out a tweet mentioning you, mute it. Thanks, man. Oh, this was so...
I'll just send a tweet to M5STACK.
You do that.
I designed a little board for Yillis. Can you maybe supply him 16 atom matrix for this insane build? And let's add the photo. Command V. Here you go. This will explode.
Oh man. I want to virtually hug you for this. Like, this is a dream come true. Like I had this idea, and this was all initiated by Joseph, by the way, who made this on ESP8266. And I said, well, we need something that have a designated MCU per channel, and this I could not imagine it to be like physical already. I can almost touch it.
Yeah. That's the good and the bad thing about this 3D preview. It's good that you can, and it's bad because you can't have it yet.
Yeah, but that's the thing with all the things. Like you can't have it yet. Yeah.
I'll off screen. I'll clean it up a bit and push it to GitHub.
Yeah.
And then you can do your thing with it.
Yeah, I'll order some and I'll ship some around.
Cool. And see you next time.
See you next time, man. See you next time. This was truly epic. Thank you for featuring in the stream. People, it's almost 11 o'clock. We're signing off. So, yeah, I hope you liked it as much as I do. Like my... adrenaline is like raging through my body of all the excitement, and I'm not able to sleep for a while. This is truly epic. Thanks, boss, every time for joining the stream, for bringing all the love into this. Really value it. Thank you very much, man.
Hey, until next time.
Until next time.